Hey guys, it's Rhiannon from Laser Everything. In this training, Kyle did a great job explaining how to use a rotary and engraving tumblers, and we wanted to share it with you, so check it out right now.
All right, what kind of rotary are you using? Are you using like the typical chuck rotary that came with it, or?
Yeah, just a chuck rotary.
So what we're gonna do before you hit test, kind of take like a reference of where basically the top is. You have the red light on?
Correct,
Your
yes.
laser? All right. So if the red light is centered on the cup, ideally what we're doing is we're looking to get a full 360-degree turn when we hit test.
Yeah.
So if we use I usually use a piece of tape,
Mm-hmm.
and it doesn't matter what kind of tape because we're not going to be burning the tape in this case, just as a reference. So if we stick the piece of tape, like the edge of it, right on where the center of the red dot is along the cup, we can use that as kind of like a guideline as to where we are.
Like that, right?
Yep, 100%. Perfect.
Okay.
All right. So what we do is if you hit test now, and right now you have it set up at 5,000 steps per rotation, and essentially that's just how many pulses the software is expecting for the laser to make a full 360-degree turn on that chuck.
Okay.
So if we come up short, we're going to go with a higher number. That's common. If it comes up too big, which I don't think it will, but if it does, then we have to go with a lower number is really the idea behind that.
Okay. Nope. It's got to be a bigger number.
About how much turn did you get out of it?
It was just about 3/4, maybe a little bit more.
Okay. So you probably have, for steps per rotation, let's try 6,400. That is basically the most common value. What ends up dictating that number is the driver inside the machine that runs the rotary.
Dead on.
That's what I like to hear. If essentially you have an image right on the screen, if you're expecting it to be a certain width, so in this case you have like a 6 1/4 wide design, and if your steps were too small, it's going to end up shrinking that design, right?
Yeah.
And what that ends up giving you in the long run, significant line problems, because what ends up happening is it's expecting more rotation in the cup, and then when you go to mark the next line path with the laser, it's overlapping way too much. Okay. So it's like overburning certain areas essentially. So that's 90% of what we see in terms of rotary problems right there is you already solved that. We have the rotation set up. We want to go ahead and size something up and run a project.
Oops.
Yeah.
Use something more basic.
If you want, we can validate sizing too. So if you set it to like a really easy value to measure, like half an inch, whatever you want to do, just something super easy you can visually see and measure easily.
Does it got to be proportional?
Doesn't have to be. It could be anything.
Okay.
It could be oblong. It doesn't really matter. But what I like to do when I'm tuning in a rotary is I'll take like a rectangle or a square, something with nice hard corners, because that's going to tell me if I have more tuning to do. And also just something with square angles and hatches make it much easier to tune split size as well.
Okay.
The laser already has like a limited purview of how wide it can see because of the lens. But what we're doing with split size is we're actually bringing that way narrower. And the reason why that's important is when you start projecting around a curve on a rotary, if we go too wide and then rotate the cup and try and line up edge to edge on something we marked versus something we're about to mark, it makes it incredibly difficult to be consistent. So if we bring that into a much closer value and mitigate some of that curve, it makes it much more consistent, and it makes lines basically pair up way better. Let's burn it. This isn't a cup you care about, right?
No, I've got tons of cups that are destroyed.
All right, just wanted to make sure.
No, I got plenty.
I don't want to burn through your stock, you know.
I do that on my own time. So the split size and overlap are pretty good.
What I usually do with my rotary work, I actually run pretty much always 0 overlap. Sometimes you'll find it's necessary, but I err on the side of quality versus speed.
Yeah.
So like if a cup's going to take me 8 minutes or 6 minutes to run, I'd rather spend the 6 minutes rather than save 30 seconds or a minute tuning for the absolute fastest I can make it.
Mhm.
Because at the end of the day, I'm just going to burn through way too much product trying to get it that tuned, you know?
Yeah.
If you were doing 800 cups a day, that might be a different story. For the vast majority of people, it's just better experience for everyone involved to err on the side of quality versus speed anyway. For split size, so there's a couple ways to approach split size. The safest, most reliable way, which is like the old school way that Alex actually teaches in the older videos, is he pretty much pairs up the split size with the line interval. So if the line interval is 0.025, for example, he would set the split size to either 0.025 or like 0.05 to double it. So essentially you're getting one line per move, and it makes it a little bit more consistent, especially if you're like a job shop. So the reason why he does that is when your diameter on your cup changes, it's going to affect what your ideal split size is. When you're using much, much bigger split sizes where you can fit dozens of lines in it from the parameter layer, the diameter is going to make a huge difference in how those lines meet because of the lens warp in the diameter of the cup. If you wanted to go the absolute safest route, if you do different size cups all the time and you're okay with spending an extra couple minutes on a cup, that is how I would probably suggest doing, is sticking with a split size equal to or multiple of the line interval. Pro tip, if you can avoid it, don't use crosshatches unless you're working with larger split values. That's the other reason why CO2 gantries are really efficient at doing cup. They either do unidirectional or bidirectional, so scanning wise, but they don't do crosshatching. You just run the length of the cup and that's it. Let's set the split size to 0.025. Go ahead and click OK. So the rest of the settings are okie dokie. You got a 50 watt, right?
Yes.
And are you rocking a 300 lens?
Correct.
All right. The default values I start with are 750 speed. On a 50 watt, you'd be at probably 85% power. And frequency, I usually rock 80 kilohertz. And then a line interval of like 0.025 should get you going. Typically with powder coat, we defocus. I wouldn't worry about that right now. We can just focus right to the top of the cup. The reason why we defocus is because if we're looking to keep like the metal as clean as possible and untouched, it's easier for a fiber to affect the metal than it is the powder coat.
Yeah, I've noticed.
Yeah. So the reason why we defocus is because with that reduction in power density, it still has the same ease level as it would with the powder coat, but it makes it harder to ablate the metal. So we can work on tuning that after, but typically with like a 200 millimeter lens, I defocus it like 3 millimeters or so. The downside to that is if you're looking for accuracy or if you're doing a full wrap, it's going to affect your scale and it could affect things lining up properly. So I try and do my best to do as much as I can without defocusing. If you don't do full wraps and that's not really a concern, then it doesn't matter. You're going along the y-axis, right? So left to right scanning is perfect. No crosshatch is perfect. And even though auto rotates on, we're only doing one pass, so should be good.
Yeah.
Yeah.
Should I just turn that off?
Yeah, you know what? I would. If this setting ends up working really good, then we can just save it and then it's in your library. So
yeah.
But yeah, should be good to give it a run. Oh, object diameter, is that already set to the right size?
Yeah, that should be right.
Should be good. It matters a lot less on chuck rotary because it doesn't really affect the math like it does on a roller.
Yeah.
Where it's dealing with multiple like ratios and stuff for how it rotates. But should be good when you're good.
All right. All right, we don't need to go the full 2 inches. Yeah, that came off really nice. I mean, it toughened up the stainless below it, though. It kind of looks like a brushed bottom. This is what it kind of looks like.
Okay. Did it affect the brush finish so that it looks like it's a vertical brush now instead of a horizontal?
Yeah.
Okay. So what we can do, we have a couple options. So the settings I gave you were like a modified version of my starter setting for my 60 watt. So what we can do is we can back down the power even just a little bit more if you wanted. It'll be a little less aggressive. And that value is going to kind of change based on like if you get a different batch of cups in, for example, right? So like if the coating is just a little bit thicker, or if you switch to like a purple tumbler instead of a black one, or whatever. If that worked good for you, we can save that into your library as like a starter, and then we can tune for this cup if you want it. We have a functioning setting. Is the height of the box seem correct to you? Because I think we stopped it early, right?
Yeah, I stopped it because I'd stopped it at like it was just over, a half inch, and
okay. So whatever the long orientation is, right, should be pretty much spot on at 2 inches. If it's not, we can go through tuning on that.
It's about an eighth off.
Okay. And you're 100% focused, right?
Yeah.
Okay. Do you notice any buckling or bulging or curving in like when you're doing squares or anything?
No, I mean overall, like my lines are crisp. I mean, I engrave some really small, fine details too, even with the 300 lens, and it comes out really good. So I mean,
so let's not mess with the calibration itself. Let's just validate scale.
Okay.
If you could go to the square tool, draw a square for me that's like, let's go with 250 millimeters square. Yeah. And let's center that. So if you just hit P on the keyboard, and let's switch it to line mode. And for settings, let's do like 500 speed, 80 power, and it should burn nicely for you. What we can do with that is we can measure based on that. Do you have a ruler that measures in millimeters, or is it inches only?
No, I got this guy.
Okay, cool. Just make it sure.
It's 246 and a half.
Okay, cool. Is that left to right or up top to bottom?
Left to right.
If we close the framing window and we go to device settings, so the wrench icon. All right. So we have two Galvos. We have Galvo 1 and Galvo 2. It's just relation to the mirror that it's controlling. So left to right is our x-axis. So to the right of where it says scale, there's the 3 dots button. Let's smash that. So requested size, we were asking it to do a 250, right?
Yeah.
And so let's type in 250 for the top one. And then measured size, we got 246.5. And it's going to adjust. So below that, you have current scale and then adjusted scale. So it just adjusted the scale for you live. So that's all set.
Okay.
So let's measure top to bottom and make sure we're good on that one. And you should also be able to see left to right. It should be right on like 250 now.
Yeah, left to right is dead on.
All right, cool. Good stuff.
So then top to bottom was the same, just shy. So we had to.
Yeah, got to bump it up. So we're scaling the y-axis now. You got it.
So 250, and we measured 246.5. Okay. Yeah.
Good stuff. All right. Since the other details of the lens calibration were good, we just focused on scale. One tip that I'm going to preface what we just did, I made sure you were centered with your test box. Let's say your head was not perfectly over the middle of the table and you shoved it over to the left, the test box.
Yeah.
You're actually making the test box come out of the corner of the lens, and it'll actually cause a skew, the sizing sometimes. So we want to make sure we're testing about 80-ish% of the lens from the center.
Okay.
Always from the center. Outside of that, you should be good. But we're good on scale now. Did you want to try doing like a full wrap design or something a little more complex?
Do you know good settings for like a bare stainless tumbler?
Bare stainless, I really like doing anneals on bare stainless. So
Okay.
it comes out kind of like a blued stainless. And it holds up way better because it's not actually engraved. What ends up causing stainless tumblers to rust is when you ablate the surface and you end up like pitting it out. It just creates so much more surface area without protection. But like an anneal is already like a protection layer, and then because you're putting that right on the already protected surface, it just comes out pretty. Another option you could do, but is really challenging, is a Z-mark, where you get like a really deep black. But I've had a lot of problems with it where I just haven't spent enough time tuning for it. But it's really difficult to be consistent with it. It gets really liney sometimes.
Mm. Yeah, I think that's what happened to some of mine. Because I do a lot of stainless stuff, which I anneal and it looks good.
Yeah.
But the tumblers just, I don't know if it's just they're cheaper or what, but I just can't get the same effect out of those as I do like a lot of my other stainless products that come through here. I don't know, for some reason the tumblers just kick my butt on the fiber machine for some reason. We're just using the rotary in general.
It could be the focal field and the split size.
Mm-hmm.
It's just it doesn't like it. We can fuss around with that a little bit really quick after we do one of these.
Okay.
With a full wrap, right? You want the long orientation to be basically the diameter, right?
Yeah, which would be 11 inches. It would be it'd be like it's like 10 7/8.
Okay.
But 11 will work.
Yeah. So another cool trick. So if you're working with, like, for example, like a ring where the tolerances are super tight, you click on the rotary menu up on the top. You can actually type in the object diameter. It'll auto correct your circumference, and I'll just copy that entire value out and paste it to get my width in the like the vector sizing when I'm scaling it.
Oh, okay.
It's just a little shortcut that I use when I'm resizing stuff and I'm in a hurry. And then it makes it way harder to like mistype a decimal or something. It's kind of a built-in circumference diameter calculator.
Yeah.
If you leave it as a line, it'll mark super quick, but we can also see if it's meeting up on the ends easier.
Yeah.
It'll make it a much more defined end spot where we can see if we're overlapped. If we're overscaling on the height just a little bit by like 1/8 of an inch, we're expecting it, but
yeah,
it'll tell us if there's anything crazy going on. You're gonna want to change your speed and power. It's gonna cook it.
Oh.
Before we did 750 speed, and I think we did 85 power at 80 frequency.
Alrighty, I'm gonna start it.
Sounds good. It'll be the fastest full wrap ever.
Yeah, I know. That's the one reason why I tell people I don't like doing wraps is 'cause it's just so time consuming, and when they hear the price, they're like, "Oh, that sounds expensive." I was like, "Yeah, well,
it takes forever."
Yeah, it takes forever, and then you want me
and
to.
There's a lot of margin for error that you got to account for too.
Yeah, exactly. And you mess up one of those cups, I'll tell you what, them Stanleys are not cheap, and I got a lot of them.
You know, it's funny. I was talking on the podcast. I think it was last week, not this week, but somebody made mention of like what they charge for a Stanley. And I wasn't kidding when I said I will charge 2 to 3 times more to mark a Stanley than any other cup, just because of the cost of replacement is so high. Where like I can get a blank typical cup for like $6 to $10, right?
Yeah.
But like a Stanley, you have to go to like Target or order it off Amazon or whatever. You're paying 4 to 6 times as much.
Yeah, they're like $50.
Yeah, if I screw one up, I'm already in the negative. So I have to account for that somehow. Yeah.
Oh, this is like dead on. Perfect. That was kind of nice.
Yeah. Essentially, if you wanted to do like a full wrap on one of those brass rings, it's going to be the same thing. The tolerances are going to be a bit tighter. Like where with this, we knew we were kind of an eighth off potentially. What I would typically do with something where it's going to be tighter tolerance and I want it to meet up perfect, and I'll measure the diameter, and then I'll go into the rotary tool.
Yeah.
And I'll drop the diameter in and I'll make it give me the circumference back. And that's where I'll copy it and dump it, and I'll resize the entire pattern by that. Because then it's set. There's a couple of variables that affect whether or not your sizing is going to match your output properly. And the biggest one that becomes a problem is focal height. So if you're not super consistent with your focal height, like if it varies a couple of millimeters, on a 300 lens, it's not going to matter as much. But on like a 110 or a 70 millimeter lens, if you're like deep engraving brass, it's going to make a much bigger difference. It's kind of like when you take a movie projector screen, you back it up a couple of feet, and it's like now it's the size of the entire room.
Yeah.
It's kind of the same concept where it's just a much smaller lens. It was tuned for a much smaller field area. So if you're just that much more percentage out, it's going to make a bigger effect.
Yeah, I usually leave this guy set at 300, and then my other one stays at 110 or 100. I think it's 110 it's set at. But, I mean, I try not to mess with changing lenses and, like, my red dots. I just try to need to buy 2 more lasers so I don't have to touch any of the lenses.
Yeah.
But that's all money.
Consistency.
Yeah. Yeah, exactly. Because switching things out and adjusting stuff, I've noticed, is just a pain in the butt.
Yeah, it adds another variable too. So, did you want to try doing an anneal on a stainless?
Yeah, like this is kind of what I got. I don't know. There's a bunch of test lines on there too, but that's about what I can get.
I think so. That was an anneal pass, right?
Yeah.
I think that probably came out pretty good.
Yeah.
Did the letter look nice and crisp on the edges for you? It's difficult for me to see through the camera, but
yeah, I mean, yeah, my camera is terrible, but yeah, I mean, it came out really good. It's just when I went to go to like try to full wrap it and stuff, it just seemed like that's when I was having problems on engraving it and stuff, and trying to get this nice anneal to do it while rotating.
Right. So we have a couple options, right? So with an anneal, right, you got to be very careful with the split size. So if you stretch too far, it's going to make lines because it's going to do like a narrow band overlap. Sticking with the split size, like I suggested, is going to be really good for that. If you were using the default split size of 5 millimeters with a 0.1 overlap, it's going to do weird, crazy line stuff.
That's probably why.
Yeah.
Okay.
That'll do it. So if you want to give it a try just to sanity test it, we could do that. So what I do is I make a box and I make a couple of strips like this. And what I'll do is I'll rotate this at like a 45. And I'll duplicate it a couple of times. And duplicate this one, and I'll rotate it like 90 degrees. Just so we get a couple things here. And I'm going to combine all of these. So I'm going to grab all of the lines, and I'm going to weld them together using the Boolean tool on the side. And now I'm going to grab my square, and my lines, and I'm going to subtract. So you just have a couple of lines that kind of meet up, right? Inadvertently, it's not going to match up, but it doesn't matter. Because what you're looking to do is you're looking to see how these interact with jumps between split sizes.
Okay.
So let me center this. So if I set this up just like I'm on a rotary, right? Like I turn rotary on, and we have our split size set at like 0.025 or whatever our split size is. Let's just say this is all set up, and I want to burn this pattern as a fill. Okay. We could also invert it so it goes the other way, but it doesn't particularly matter. As the laser passes, what we're looking to see it do is jump here, start here, and continue, jump here, and start again. And the split size is essentially in segments. So as we do different segments, what we want to see is that this area along here is matching up. So if it doesn't match up, it means the split size is too big. And what I do is I burn this onto the cup itself. And it's basically, it's like a 2-inch wide strip that's 1 inch tall. And it goes around the cup long ways. And what you want to do is you want to validate that this line is matching up all the way down. And you're trying to avoid jaggies. So as clean and as straight of a line as possible. And if it starts getting jaggy, you know, you have to drop your split size down. Let's say it's 0.025, right?
Yeah.
So I'm going to take 0.025 and I'm going to use that as a multiple. So anything in quarter scales will work in this. So instead of 5 millimeters, I can do 2.5. I can do 2 1/4, 2, any basically even multiple. And what I'll do is I'll drop it down, and there's no rhyme or reason to the drop. You're just going up and down until you hit a point where it's happy. So if 2.5, jumping from 5 to 2.5, it's still not happy, you know you got to keep going down. So it's more of an on and off switch. You can always go too low and it'll be fine. But if you go too high, it's not going to look good. Your quality is going to suffer if you're still too high. But yeah, just this concept has been super helpful for tuning in my CO2 Galvo. And I'm working backwards, including it into my fiber rotary tuning for split sizes to help save time. And in situations where you need to account for time, like if you wanted to start specializing in full wraps, this method will help you out.
Cool. Alrighty, that should be it for now. Next time I'll get a list of stuff to go over.
Yeah, set yourself up with a list of goals and questions, and we'll hammer through it, and we'll shove as much as we can in that time frame for you. If you have any questions or anything we can help you with, just reach out.
Alrighty, I will do. Thank you, guys.
Yeah, thank you.
Anytime.
Thanks so much for watching this episode of Laser Everything. If you got value out of it, don't forget to smash the like button. Let everyone else know the content is good. Don't forget to subscribe and hit the notification bell so that you get notified the next time we post an episode. If you really like this one, check out the Laser Master Academy. It's the #1 way to support the channel. And we'll see you in the next one.